Very well. In this screencast, we get to talk about the standard addition algorithm. It's familiar to so many people, but when we explain it to small children, it is helpful for us to know why we do what we do, why it matters how we do the algorithm. So what I'd like to do is I'd like to add 53 and 21. There is nothing fancy here. Everybody knows how this goes, right? We add the 3 and the 1, we add the 5 and the 2, and we're done, right? Why? Place value says this is the tens place, and this is the ones place. So when we add 3 and 1, we get 4 ones. We write that 4 in the ones place because 3 ones and 1 1 is 4 ones. In the tens place, we have 5 tens and 2 tens. That's 7 tens. And so we write the 7 in the tens place because it's 7 tens. And then we have 74, that's 7 tens and 4 ones, that's 74. And by using our place values, our understanding of place values, we have the standard algorithm. So the key is to keep place values in mind. That's the key. So here's the question. Do we get the same answer in base 8? If this is a base 8 number, if this is a base 8 number, do we get the same answer? Well, this is still the ones place. This is now the eights place. 3 ones and 1 1 is still 4 ones. And 5 eighths plus 2 eighths is still 7 eighths, right? So we get an answer in base 8. So what happens if these are base 6 numbers? What happens if it's not base 10 or base 8, but base 6? Well, these are the ones. These are the sixes. 3 ones and 1 1, that's 4 ones. 5 sixes and 2 sixes is 7 sixes, but 7's not a digit here. 7 sixes is 42. And 42, well, that takes us into the 36's place. 42 is 136 with 1 6 left over. We keep the place values in mind, and we change the representation because we can't write 7 as a numeral in base 6. What did we do? We carried. And that's what we do. That's how this works. When we add 47 and 35 in base 10, when we add 47 and 35, this is the ones place, this is the tens place. 7 and 5, that's 12. But you can't write 12 there. That's not okay. You can only write a numeral there. So we think about this 12, so it's 7 tens and 12 ones. That's 7 tens and 12 ones. But those 12 ones, that's 1 10 and 2 ones. So now there are 8 tens and 2 ones. And that's what happens here. That's what happens here. We write the 2 down here because there's only 2 ones after a regrouping. And then we quote unquote carry the 1. We quote unquote carry the 1. Why? Because these 12 ones have a 10 in there. And we bring that 10 to the place where it belongs. And then we have 1 10 and 4 10s and 3 10s. That's 8 10s. So we carry the 1 because we need to put a 10 where it belongs. That's the huge key. That's the huge key. Does this apply to other bases? You betcha. Let's add 2 3 base 4 to 3 3 base 4. If we add 2 3 base 4 to 3 3 base 4, well, 3 plus 3, that's 6. But the place values are 1s and 4s and 16s. So when we think about 6, 6 is a 4 with 2 left over. So we bring the 4 into the 4s column. And then we have 1 4 and 2 4s and 3 4s. That's 6 4s. 6 4s, that's 2 4s and a 16. It works exactly the same in other bases. We regroup in such a way that lets us hold place values constant. This 6 is 1 4 plus 1 2, and so we move that to the column where it belongs. This 6, the 6 4s, 6 4s are 24. That 24 is 116 plus 2 4s. So we move the 16 to the column where it needs to be. You may want to, as a separate exercise, you may want to think about how you explain to small people how to do this, base 10, keeping in mind what the place values are. And then hopefully you'll see 9 and 3 is 12. 12 is 2 1s, but a 10. And then we have another 12. That's 12 10s. 10 of those 10s is 100. 2 of those 10s are left over. And we got it. Hope this is helpful. Subtraction's up next.